Once we know that two variables share a linear association, which we can measure by calculating the correlation coefficient R or looking at a scatter plot, then we can construct a line of best fit that models the pattern or behavior of that data in a linear fashion. In example 1, we'll consider data that we've looked at before, the number of roller coasters per country versus the amount that country has contributed to tsunami aid. We already saw that this data has a correlation coefficient of 0.8793, and we looked at that scatter plot to see that pattern visually. Now what we want to do is construct that line of best fit using our value for number of roller coasters as X, our value for tsunami aid as Y, which I already have plugged into Desmos. What we'll do to generate this line of best fit is type in Y1, the value for the variable that we have for our Y values. Then we'll use the tilde symbol, the little squiggly line, which is usually located next to the 1 key on a keyboard. M times X1 plus B. What we're doing there is typing out something that follows the format for a linear equation. Desmos is going to give us the value for R, 0.8793, which we found previously using a different method. And it's going to give us values for those two constants, M and B. So that line of best fit is called the regression line, or the regression model, and can be represented in the form y equals mx plus b. In this equation, m represents the change in y when our x value is increased by 1 unit. So it's the slope of that line of best fit. And that linear model that we constructed is y equals 2.414x plus 62.073. Something to note here is that our value for R, that linear correlation coefficient, was positive. And similarly, M, the slope of our linear equation, is positive. If the linear correlation coefficient is negative, then we would also expect a negative slope for that line, since the pattern would be decreasing instead of increasing. And we can also look at interpreting that slope by saying that if a country adds one more roller coaster, so if our x value increases by 1, then that country's tsunami aid will increase by $2.414 million. Again, the slope tells us what would happen to our y value if our x value is increased by 1. Once we have a model, then we can predict future or unknown values, but we'll also have to think about the accuracy of our model, which is how good that model is at making predictions. But we can always follow this same pattern of constructing that linear model using this same input, we'll see that line pass through, and if we're doing everything correctly, that line should look like a good fit for our data, assuming that we have a strong correlation coefficient, something close to 1 or close to -1.